Hello everyone! Today we're gonna talk about the two different types of shear stress, single shear and double shear. In the figure of the left, we can see an example of single shear. Here we have a pin which is attached to a bracket and a new member. As that new member is the member at the bottom, at which a force P is being applied. In this case, force P is pulling the member downwards, while the bracket is trying to hold the system in place, having a reaction force that goes upwards. Here we see the action that force P generates a reaction on the bracket attached to the fixed support. Those action-reaction forces generate shearing stress in the pin due to the shearing force created by P. In order for you to see that, let's take a closer look and make a cross-section right in the middle of the pin. Now, let us draw section AA to see the internal loads of the pin. Once we have drawn section AA, we can see force P, and we can also see the internal forces of the pin. In this case, we will only have the shearing force, and this is called single shear load. Single shear is load applied in one plane of an element. This happens when a single cross-section of an element takes all the shear force created by the external force. In this case, a single cross-section of the pin takes all the shear force created by the external force P. This can be demonstrated by applying the equilibrium equations. If we sum all the forces along the x direction, we can see that the shear force is equal to the external force applied. In this case, V is equal to P. Now, if we apply the definition of shear stress, we can say that shear stress is the shearing force divided by the cross-sectional area of the element. In this case, it will be the area of a circle. On the other hand, if we talk about double shear, from the figure on the right, we have one member that is being pulled by a force P, and that member is attached to a fixed support using a pin. Now, since we know that for every action there is an equal and opposite reaction, we can see that since force P is trying to pull the system down, the two brackets attached to the fixed support are trying to hold the system into place. Now, due to this action and reaction, in this case, instead of having one single plane that takes all the internal load, we will have two cross-sections of the pin taking the shear force created by P. In order for you to do that, we're gonna make a cut. But now this cut will be a little bit different than the previous one. Now the cut that we're gonna be analyzing will be the middle portion of the pin. And we're gonna call this section BB. Now, this is how section BB will look like. Now, in this case, instead of only having all the shearing force acting on the top plane, we will have the shearing forces acting on the two planes, the top plane and the bottom plane. In fact, when two cross-sections of an element takes the shear load, it is called double shear. This can be proven utilizing the equilibrium equations. Let me just define the coordinate system before applying the equilibrium equations. If I sum all the forces acting along the x direction, I see that I have two shearing forces and one external force, force B. In this case, every shear force acting on a plane will be equal to P over 2. Once we have found the magnitude of the shear force, we can just go ahead and apply the definition of shear stress. We know that the average shear stress is equal to the shear force divided by the cross-sectional area. We can say that the average shearing stress is equal to P over 2 divided by A. And this also can be written as P divided by 2 times A. If you compare the two cases, and if you let P be the same for the single shear case and for the double shear case, we can see that we will get a larger stress if we have a single shear system. And we will also have a smaller average shear stress when we have a double shear system. This is due to the fact that the shearing stress on the double shear, it's been distributed between two cross sections, the top cross section and the bottom cross section of the pin. I hope this video has helped you understand the difference between single shear and double shear. In the next video, I will be solving problems regarding single shear and double shear stress. Thank you for watching.